In this worked example, we're calculating the density of a mixture. Settle down, class. I know it's exciting, but we have to keep just moving forward with our review. I'll edit that out later so YouTube won't hear the commotion that just occurred in class as you found out. Well, we're calculating the density of a mixture in a large container in an oil refinery. Settle down. I know it's an oil refinery problem. 3 oils of different densities are mixed. No chemical activity occurs. Not chemistry class, right? The mixture consists of 1,200 kilograms of oil of density 1,100 kilograms per cubic meter, 1,500 kilograms of oil of density 860 kilograms per cubic meter, and 4,000 kilograms of oil of density 910 kilograms per cubic meter. What is the density of the mixture? There's a saying in physics that I mentioned to first and second period that I want to share with you all, but I want you to know it's not my saying. And I would never tell you all this, okay? Other than to apprise you of the fact that this exists as a saying in physics. It's kind of rude, okay? And the rude saying that's, a mainstay of physics, because like physicists can be rude sometimes, is shut up and calculate. Isn't that rude? You shut up and calculate? So I would just say, like, please be quiet and calculate, make it a little bit more polite. But the saying is just kind of like, sometimes we're just gonna like put some numbers down. Like, let's just start calculating this thing and maybe that will solve it. Like, what can we calculate from this? They give you a density, they give you a mass, what can we calculate from that? All right, so if I've got density 1,100 kilograms per cubic meter, all right? And I've got 1,200 kilograms of that oil. Okay. Density is mass per volume. So volume times density is equal to mass, right? So we've seen this before. Mass is density times volume. Well, then volume must just be mass per density, right? We can calculate the volume as the mass per density. All right, so let's do that. Let's calculate the volume of this. Volume equals mass per density. The mass is 1,200 kilograms. The density is 1,100 kilograms per cubic meter. So we can figure out how many cubic meters of this type of oil we have. It's 12/11, which I will now approximate the decimal. 1.09 repeat. At 1.09 repeating cubic meters of this oil. Let's do the same thing for these. So the volume for this one is going to be this mass divided by its density. So this one I've got more mass, 1,500 kilograms, but it's lower density, 860 kilograms per cubic meter. The kilograms cancel. I figure out how many cubic meters. You take care of the words will take care of you. The units are involved in the calculations also. Cubic meters of volume, right? Reminds you sort of what you're solving for. 1,500 divided by 860. Can anybody do that in their head like I can? 1.744186047, I think, if you do it mentally to, the billionth place or whatever. We'll just round it there to the thousandth place. So we have that many cubic meters of that one. Another calculation here. I got 4,000 kilos of this oil. Its density is 910 kilograms per cubic meter. I can figure out the cubic meters of this oil with another mental math calculation. 4,000 divided by 910. Students in class can see me typing buttons in my calculator, but YouTube believes that I'm doing this mentally. No, YouTube knows better. They know better. All right, so I have those total cubic meters of oil. Now what I want to do is just another calculation with density. Okay, what is the density of the mixture? Let's go back to make density the subject. It's mass per volume. All right, so density is mass per volume. And now I should be able to just do like a total calculation, like what's the total mass, what's the total volume? So add up these numbers to get the denominator, add up these numbers to get the numerator, right? That's a pretty safe way of solving this. I feel like maybe there's a way to say, maybe there's another way to calculate this based on like, oh, this percentage of the total density is this, you know, something like that with percentages or something. Almost like relative abundance, like when you do mass calculations in chemistry, like what's the relative abundance of this, you know, oil or something. That to me seems confusing, and maybe it's possible, maybe it's mathematically identical, or it could be perhaps a bit tougher. But I feel like this gets us the right answer. So if we do 4,000 plus 1,500 plus 1,200, what does that work out to be? 6,700 kilos of oil, and the total volume. So we'll sum 1.09 plus 1.744 plus 4.396, 7.23 cubic meters. So like that's the total volume of, you know, this mixture. So density is still mass, 6,700 divided by volume, 7.23, and I get 926.7. Pretty close to 927. Right? And then you could kind of say, well, does that seem reasonable? Like most of the oil is this, right? Like 4,000 kilograms. That sort of, you know, even the sum of these two doesn't even quite match up with how much oil I have of this density. And so it's kind of closest to that one. That kind of makes sense. You know, that it would be close to that. So choice A has got to be correct for this.